Hello, testing. Mic volume looks okay, I think. Hello. Hi, hello. Good morning, or afternoon, evening, wherever you are. We are trying, or not trying new stuff, but we are reviewing Meta/Facebook Leetcode interview questions today. I have, from the previous 6 streams of Meta interview questions, I have a list of all the questions that gave me any sort of difficulty. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 problems. 2 starred ones. Excuse me. So we will review them so I don't forget them in the future. Okay, let's begin. First up is question 1249. Leetcode 1249. Alright, I already feel screwed. I don't remember this. Minimum removed to make valid parentheses. Given a string of blah and lowercase English characters, your task is to remove the minimum number of parentheses or blah in any positions so that the resulting parentheses string is valid and return any valid string. Formally, a parentheses string is valid if and only if it is the empty string, contains only lowercase letters, or it can be written as AB, where A and B are valid strings, or it can be written as A, where A is a valid string. Okay. I think it's starting to come back to me. I think we're supposed to iterate through everything here, and then when we see a left parentheses, we add it to the stack, and then when we get to a right parentheses, we pop the previous left parentheses from the stack, because it's like these two are corresponding to each other. This one closes that one. When we get to this one, we pop this left parentheses from the stack. We don't add any of the right parentheses to the stack. That's kind of useless info, I guess. And then we also store some sort of list to track which parentheses we get rid of. So for example, when we get to this parentheses, we see that we have no more left parentheses in the stack. That means there's no parentheses that closes this. Yeah. And we have to add this into the to remove list. Oh, and also any remaining parentheses in the left parentheses stack in the end will also needed to be removed. Oh, hey Dragon. Dragon says, did you join contest? Oh no, I still haven't joined any contest. When was the last one? Leetcode contest. Oh, contest. Saturday. Oh, it starts in 10 hours. Oh, shizzle. I might have a conflict during this time though. I think I'm playing D&D with friends. Yeah. Oh, 7:30 a.m. Dragon says, have fun. Thank you. But yeah, we're doing minimum removed to make valid parentheses, which today's a review day, by the way. So I'm doing all the meta questions that have stumped me. I think I remember how to do this one. you get a stack. We should store the indices of the left parentheses, right? That's useful information. Integer s is equal to new stack. And then hash set integer to remove equal to new hash set. But yeah, how are you doing today, Dragon? Long time no see. For int I is equal to 0, I is less than s dot length, I plus plus. Yeah, so if it's a left parentheses, char c is equal to s dot character at I. And if c is equal to left parentheses, then you add it to the stack. S dot add. No, stack is push, right? Push I. Should we sanity check right now? I like sanity checks. Let's print out what our stack looks like right now. Stack. Maybe we should give this a better name. Stack. Stack. Why do I keep saying strack? Okay, give me a minute while I sign into Leetcode. S dot length. Oh, missing parentheses. Oh, stack dot push. Okay, our queue has 0, 1, 2, 3, 4, 5. Okay, that's correct. Very good. So else if c is equal to closing parentheses, we need to look for the case where okay, so there's two choices. The stack is empty. Okay, there's no corresponding opening parentheses. Stack dot is empty. Stack dot pop. Else if stack is not empty, then you wait, hold on, I got it backwards. If stack is empty, then to remove, you add my current index. And else, what do? That means stack is not empty, so I just pop it. To remove dot stack dot pop. Yeah. Okay, let's try this again. In the end, we should have, to remove, we should have just the last closing parentheses. To remove. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, perfect. What do we have for this? 0, 1, 2, 3, 4. Yeah, that's correct. What is this? 0, 1. Yeah, we gotta remove those. 2, 3. That's correct. Okay. We also need to add everything in our stack to remove in the end too. That means those opening parentheses are never taken care of. So for, can I do this with stack? For int opening and stack to remove dot add stack dot pop. Oh, I can just do while not stack dot is empty. Semicolon. Okay, yes, this is correct. Very nice. And then I need to make a string builder and iterate through all the indices and add only the indices I want to take. Yes. String builder SB is equal to new string builder. We'll copy this schmo again because we need to iterate through everything. So if to remove dot contains I, then we continue with the loop and don't execute the rest. Continue. And else C is equal to the current character string builder dot append C. And in the end, you return string builder dot toString. You know, something I really want to do, like to add to my stream, is to add a timer. I'm really curious how long it takes me to do every problem now. I heard in Facebook they expect you to do medium problems in like 20 minutes, which is absolutely ridiculous sounding. Beats 38%, very nice. I will take the W. Also, I feel like I'm missing it is the empty string. That's the base case that I missed, right? S dot, if S dot is, does string have it's empty? Dot equals this return S. But that was a little faster. I'll take the W. Oh. Alright, very nice. I had this problem written down as a starred problem, meaning it gave me a lot of trouble, but I guess now that I know the solution, it's not too bad. Yeah, I think it took me only like, when did I start? 9:05, so 15 minutes. I improved. Yay. Oh, also, you know, I've been advertising this a lot. At 4 p.m. PST today, I'm battling out with Call Me CJ. CJ, another tech VTuber. We're gonna compete in LeetCode, Leet Rooms. We're gonna use the Chrome plugin Leet Rooms to make a LeetCode room. It will generate 4 random questions. Whoever does the most in 60 minutes wins. Gonna be at 4 p.m. He actually has real industry experience. He just finished a DevOps software engineering internship, so he's actually LeetCoding himself somewhere. So he might actually kick my butt, but it will not stop me from trying to kick his butt. He apparently said that he hasn't LeetCoded in a while though, so maybe it's more fair than I thought. Yeah. I am very nervous and excited. Okay, next question that I've started is 314. LeetCode specific. Binary tree vertical order traversal. Yeah. Excuse me. This is a premium problem. Time to use my brother's account. Leetcode 314. I cannot type today. There we go. Let's just confirm. Okay. How screwed am I here? Binary tree vertical order traversal. Given the root of a binary tree, return the vertical order traversal of its nodes values, i.e. from top to bottom, column by column. Oh, I remember this problem. If two nodes are in the same row and column, the order should be from left to right. I remember this. It's really hard. Also, I realized chat is covering my face. Bam. Cool. Return the vertical order traversal of its node values. Okay, yeah. I don't remember exactly how this is done. I just remember it's hard. So, I remember we need to do a DFS, go through every single node. The DFS will track which column I'm on in the parameter, and then I will store all of the nodes. Yeah, all of the nodes with their row number in a hash set. The key of the hash set will be the column, because that's the only thing I know from traversing it DFS-wise. So unfortunately, I'll also have to store the row that it's in. Wait, can I track the row? Oh yeah, I can track the row in DFS too. Every time I recurse downwards, I add one to the row. That can be done. And then I also have to sort each key or each value in the hash map by row, which is going to be a hassle too. We're going to need a fancy comparator for that. So DFS, store, hash map, key is a list of nodes and its rows in a column. I'm doing a horrible job explaining this, am I? Each key in the hash map will correspond to a column. And the values will be a list of the node and its row. And then we'll have to store each value in the hash map by row later on. And then we return it by column. Yeah. Okay. Way easier said than done. Here we go. Oh my goodness. Okay, so we need a hash map. What is the hash map? Integer, which is the column. And then we need to do something kind of tricky, which is list integer Yeah, ideally I want to store the actual node, right? But it's kind of hard to do that in Java. So I do a list with the value of the node and the row of the node. I should probably leave a comment to make it easier to read. Key is equal to column, value is equal to value comma row. Ooh, this is gonna be such a hassle. Equals columns is equal to columns map is equal to new hash map. Okay. We will do a DFS called fill map. We'll pass in columns map in here. Okay. And for a sanity check later on, I guess, we'll do system.out.println columns map. Return null. Public void columns map, which will take in this. It's supposed to be called fill map. Okay, nice, at least it's compiling. That was sanity check 1. Excuse me. Okay, time for our DFS search. What do we need in DFS? The current node, right? So we'll need tree node and we'll also need to store the column and into row. Well, we need the column for the key of the map in the row because we need to actually store it. So this helper method will be, we'll input the root node. We are on the 0th column first. This will be 0, this will be -1, 1, because we don't know what our min and max is at first. 0, row is 0. Okay. Okay, let's make the key is the column. Oh my god, it's call me CJ. Hi CJ. CJ says, hey Chet, when it comes to me recording my Cypher stream, how do you want me to handle my music? Oh, you can put any music you want. Yeah. CJ says also, I quite literally never touched binary trees, so you're already a lot further along than me. Alright, well, hey CJ, we're only doing easy questions, so it should be an even playing ground, yeah. I have no idea what I'm doing also, by the way, in case you're wondering. But hi CJ, hello. I'm looking forward to battling you. CJ says no, as in to be as part of the VODs, I can have it play in my own ears, but not be in the recording. Oh, I see. Yeah, if you can do that, that'll be good. Yeah. You might need to show me how to do that later too, because I just wanted to, well, I just plan to play my own music all the way. because I can either use my stream save playlist or listen to my work playlist or stuff that may or may not. Oh, I see. Okay, I see what the concern is. Yeah, if you're using copyright music, please mute it. The music I'm using is not copyright, so it's fine on my end. Yeah. Yeah, thanks for letting me know. If it's gonna be DMCA'd, yeah, please mute it, please. I mean, not that I'm even monetized on YouTube anyway, so it should be fine. But preferably, yeah, mute it. Thanks. The key here would be the column. My brain, it hurts. Okay, what's our value here? The target value is like, we want to do the value of the node in the row, right? CJ says, and I can send you a vid on how to separate your music from bots. Ooh, awesome, thank you. So we'll do list, integer, the value is equal to arrays.addList, key, wait no, n.value, comma, row. I think that's how it works. I used to think you have to cast the result of arrays as list. But apparently, I don't know if it's a newer version of Java thing, but now you don't have to do it anymore. Okay, that's the value element. The actual value is wait, is it even more complicated than I thought? Hold up. Alright, see you in 90. Lurk. Hey, alright, thanks CJ. Okay, I have to store a list of integers. I'm starting to see. Oh, this is gonna be so complicated. A list of integers. Okay, that's my columns map. That's my value element. The actual value of the array is like a list of integers. All right. List integer. Okay, we will get it from the map if it exists. So value is equal to columns map dot get or default the key, and if it's not there, you just make a new list. New list. Array list. Okay, sanity check. Let's make sure this compiles. Okay, nice, it compiles. All is not lost. Okay, so in value, we add the value element. And then we add it back into the hash map columns, map the key is equal to the value. And then we recurse on our left and right. So fill map, we do n.left, the column would decrease by 1, row would +1, and the hash map would remain the same. Columns map same for the right, n dot right, except column +1, row +1, columns map. Okay, sanity check time. Let's print out our columns map. Columns map dot put. Cannot read field valid because parameter is null. Oh, I see. Base case is missing. Pain. If n is equal to null, then you return. At least it's iterating though. Okay, what do we have here? We have, in column 0, we have 3, 0, 15, 2. In column -1, we have 9 and row 1. Column 1, we have 20 and 1. 2, we have 7, 2. Okay, that's really good. We are storing it. We are storing it well. Okay. Okay, now we need to sort everything by their row. Sort. Okay, so for every single column value, every column list in our hash map, we need to sort them by the row, which is the first element in the array. So we need a new comparator. Okay, for every single in columns map, what happens? The list of integers. Holy, why does it have to be this complicated? Is equal to columns map dot get column Okay, one more sanity check. I'll just call it column. Okay, it's going. Very nice. Okay, we need to sort this column by the first element in the list, not the 0th, so we have to be careful here. So collections.sort column. Comparator.comparing. Let's do list is equal to list.get 1, I guess. Okay, and then we can print out columns map again. I want to print out columns map before and after the sorting. Semicolon. Okay, what is going on here? It's the same order here. Should be fine. 0, 2, column 2, 1, 2. Are there any cases where the ordering will be different? Oh, here. It's different now. We got 1 first and then 3. Okay, that's good. 9, 3, 15. Okay, very nice, it's working. I remember while trying to sort it, we also need to keep track of our min and max column, because otherwise we would have to go through the keys of the hash map again to figure that out. Int min is equal to integer dot min underscore value. We'll call this min column. Max column is equal to integer dot max value. Alright, and then down here we'll update our min max values too. Min column is equal to math.min, our current min column, versus our current column. I realize I got those backwards. And likewise, our max column is equal to math.max. The max column and column. Am I doing this right? I'm so paranoid. Min. Excuse me. Okay, I think this is right. I'll do another sanity print. I love my sanity prints. Min column plus blank space plus max column. Column, oh, the key. The key is the one that's the integer, not the column. Okay, minimum is -1, max is 2. Okay, that's correct. Very nice. Okay, I have to return a list of integers. Okay, time to iterate through everything again. What a hassle. Last step is compile everything into the result. List of integers. Result is equal to new list. So complicated. Okay, for int I is equal to, well, let's call it the column. Is equal to min column, while column is less than or equal to max column, column plus plus. Let's call it column number for clarity. Column number plus plus. And then this list integer will be the actual column stuff. Is equal to new array list. And then we need to add everything from our column map into the column. List of integers. Column map result is equal to column map get column number. And then we add everything. We add the first element, no, the 0th element of column map result into column. For every list integer element in column map result, column.add element.get 0. Okay, another sanity check. Let's print out result. Print then result. semicolon. New array list. Column map. Did I name my, columns map. Why is my result empty? No. My map is correct though. Result is equal to new array list. Column is equal to new array list. Column map result is equal to columns map.get column number. Am I not getting the right column map? System.out.println corresponding map value column map result. No, we are getting that. So for every list element in column map result, column.add element.get 0. So why is it not adding? Oh, I am dumb as hell. I forgot to add into the result. Result.add column. Hey, now we're getting stuff done. And it looks correct. Yeah, it looks good. So now all we have to do is return result. Let's go. It worked. I imagine if we submit it now, we'll get time limit. Oh, very sick. I'm just going to remove all of my print statements so that it runs faster. We're at 5% now. Submit it. Just 7%. Alright, I'll take the W. Man, this problem was so annoying at first, the first time I did it. I still think it's pretty annoying. There's so much data structures involved. So I did the DFS search version. Is the breadth first search faster? Complexity is n log of n. BFS without sorting. What is the complexity of this one? I go through every node in the tree, so it's O of n, and then I sort every column. Oh, so that's log n. No, n log n. So yeah, n log n time. In the case where the binary tree is completely imbalanced, example node has only left children, this DFS approach would have n time complexity because each column would have one row. Okay, we're done with this. Let's move on to Leetcode 408. By the way, CJ, I don't know if you're still here. Today's a review day for me. So in case you're wondering why I'm actually able to do this problem, like, not in an hour, that's why. Okay, Leetcode 408. This is a premium question too. Very well. I shall use my brother's account again. Okay, this claims to be an easy question, but as we've seen in the past, it's not. I contest the difficulty rating of this. Hold on, let me hydrate too. Excuse me. A string can be abbreviated by replacing any number of non-adjacent, non-empty substrings with their lengths. Wait, what? By replacing any number of non-adjacent, non-empty substrings with their lengths. The lengths should not have leading zeros. What does it mean by non-adjacent, non-empty substrings? Oh, like they can't be next to each other? You have to have at least one character between the sections that you abbreviate. The length should not have leading zeros. Okay, don't see why we would have leading zeros. For example, a string such as substitution could be abbreviated as, but not limited to, that's 10, SB for U4. Okay. The following are not valid abbreviations. Right, because they're adjacent, has leading zeros. Replaces an empty substring. Given a string word and an abbreviation, return whether the string matches the given abbreviation. Is it bad that I think that this doesn't look that bad? Okay, the hard part would be the integer parsing, I guess. So if I get this, I guess, I would iterate through every single letter. I would have 2 pointers, one on the first string, one on the second string. If I get to anything that looks remotely like a digit, I will parse it. I will move the pointer until I don't see another digit, and will parse the entire digit. And then I will skip that many characters in here, and then I will continue ++ again. Is that gonna work? And if one of the strings ends and the other doesn't, then that's bad too. I have to watch out for that. Okay, and of course all the letters have to match. Okay, I think that sounds like a plan. Okay, so 2 pointers. Int word index. Oh, I remember why I struggled with this problem too. I think I got really confused in the variables I used, so I have to be careful. Word index is equal to 0, int abbreviation index is equal to 0. And while both are in bounds, word I is less than word dot length, and abbreviation is less than abbreviation dot length. Gotta get the current character. C is equal to hold up, it's different for both. So word character is equal to word dot character at word I. Character abbreviation character is equal to abbreviation dot character at abbreviation character. Ooh, I'm just beginning the problem. I'm getting so confused already. Should we do a sanity check? Println word character plus space plus abbreviation character will return false by default. Abbreviation index no, I had an infinite loop, didn't I? Word I plus false. Abbreviation I plus false. Okay, it compiles. That's always a plus. Okay. So first off, we need to check if it's a digit. So if abbreviation character, wait, how do we check digits again? Character dot is digit, abbreviation character okay, we need to read the entire digit, so string num is equal to just the abbreviation character plus a string to turn into a string. Okay, so while abbreviation index plus 1 is still in bounds, and the next character is a digit still. Character dot is digit, abbr dot character at abbr index plus 1. Keep reading them characters. Character abbr next character is equal to character at here, num plus equals abbr next character. Okay, I'm so paranoid. I need another sanity check. Let's print out the character. Print ln num full num. Oh no, another infinite loop. AVBR index plus plus, isn't it? We need to move to the character that we used. Full num is 12. Okay, nice, nice. We're reading the full character. What do we do from here? We parse the character, the integer, and then move our pointer in the word that many steps ahead. Yeah. I think I gotta be careful here. I might get off by one thing. So if I'm on Z here, and then I'm on A, and I'm told to move 4. 1, 2, 3. So I move 3 instead of 4, because it includes the current character that I'm on, right? 1, 2, 3. Yeah, okay. I gotta be careful with that. Okay, okay. Move that many forward. Int num to int is equal to integer dot parse int num, or int I is equal to 0 and I is less than num to int minus 1, because off by 1, I plus plus. Word I plus plus. I hope I'm doing this right. So if we're at Z, so when we get to A, the abbreviation character will be 4, 1, 2, 3. Wait. We're at here. 1, 2, 3, 4. Oh, and then the next plus plus would take us to N. Okay. 1, 2, 3. Okay, okay, I think this works. Oh my. Yeah, okay, okay. It takes us to the N. Very nice. Okay, so if it gets through everything here, if either one is not out of bounds yet, so if word I is less than word.length, or abbreviation is still not to the end, return false. Else, if you got through everything, return true. Hey, it worked. Submit. No. Output is true, expected false. Oh. We're close though. We are close. What do we do in this case? I think we gotta check if it's inbounds here. If word I is greater than or equal to word.length, return false. Let's use this test case. Nice. Oh, it cannot be a 0, right? Okay. Okay, if it's a digit, if ABBR character is equal to 0, then return false. We never start with 0. Okay, we're really close. 2 more test cases. Word 3E. Oh. We need to check if it even matches, right? So if it's not a digit, we compare them normally. Else, if word character is not equal to ABBR character, return false. Wait, I'm surprised we got through most of the test cases without checking if the characters are even the same. That's crazy. Hey, we got it. Let's remove our print statements. Was that all the print statements I had? %. All right. Sure. That was relatively fast. Is there no editorial? Okay, that's fine. Could I speed this up by... I'm not sure how I could speed this up, to be honest. Is it through here? Is it worth doing a string builder here? String builder is equal to new string builder. I mean, how big are the digits gonna be? ABBR character. Okay. And then num.append num.toString. That's how string builders work, right? Okay. Are you freaking kidding me? Are string builders that fast? Are string builders that fast? What? Well, I guess they are fast. Wait, are you serious? How long are these digits they're giving us? Oh, that's crazy. Oh, wow. I'm actually genuinely really shocked. Do you know string builders are... Do they add that much? I know for strings, you need to like... If you're concatenating two Java strings, it's n time. Because you need to add... Like, you need to copy both of the strings together. Like every single character copied into another string. String builder, I guess you just append that one character to the end of the string array that's represented in string builder. But dang, I didn't think it would make that much difference. We went from like 5%, was it 5%? To 95%. Very crazy. All right, I will take the W. You know, it was a review day, but we did 3 medium problems in like an hour. I think it's cool. I think I'll call it a day. See you guys at 4 p.m. for the battle against CJ. I've also saved my brain power. Alright, thanks for coming, guys. See ya at 4 p.m. Wait, is anybody on right now? Can I try rating someone? Alright, Tenji and Prime aren't on.